What we're going to be talking about is the service button that is on the front of the controller. I'm going to talk to you a little bit about what that button is basically used for and how you can actually program that button into um, doing commissioning or testing or anything like that. So it can be pretty much used for anything that you want to use it for, because it actually is a physical part in your controller. So one of the things that the button is actually used for is if you come to here under your BACnet network and you go into IRM config and go into the property sheet. If you have 30 or more of these controllers on your network and you're setting this database up or they've been installed out there in the field already, each one of these controllers, as everybody know, there is no physical addressing switches on there, so you can't set the MAC address when you first start out the box, and the device instance number is actually preset as well. So that default number always default to 4194302, and that's what every controller will come in as. So as you bring these controllers in, you come into an issue where you have multiple controllers on your network with the same device ID. So one of the cool things about it is with that service button, you can come here to the IRM config, push the service button, and then this is your serial number for that controller. It will populate, and at this time, you can actually go in, name that controller what you want, and assign the device ID number. So when you actually do a discover, it will come up with your name and the device ID that you put in, and then you link it to the controller that as it came in. This right here is also an ID range that you can actually preset, that your first controller will start with that number, and you can set what the max number device ID that you want to use. So when you first put them on, then your controllers would range in between those. So the second option with that button is if you have a program in the controller already and you're having issues with it acting up, or you can't go back in and tell it to clear the controller or reteach the controller or do a full application download. If you power the controller off and hold that service button down for about 10 to 15 seconds and then let it go, it actually does a factory reset where it actually wipes the controller and put it back to factory default. So that is another nice little feature. And then the third one is what we're going to go through, and that is here in your controller under the IRM program, and then go to my onboard IOs. And here's that service pin button as a physical button in your program. So right now, if I take and push that button, as you can see that my output now has become true. It doesn't latch. So it is a momentary button type on here. Unlike the Spyder 30s, the Spyder 30s also have service buttons that you can actually program. The Spyder 30s are, when you push that button, it actually latches in. So if you program anything with the Spyder 30s, you have to put something in your logic to have it to go back and unlatch that feature. So part of my program that I wrote for this service pin button that I go through with you guys is is basically simulating a testing feature for my fan. So this program here is a fan coil unit program that was written using a Spyder 5 VAV controller um, on a 3 fan speed fan coil unit. So in my event program here under fan controls, here's the program that I have written. That is the wrong one. Let's see here. Okay, so this is my fan speed program here um, that is basically looking at part of my logic for my heating PID and my cooling PIDs. So it is a stage. So this is all of the programming for the staging. So encoding here is a deal where the program is also set up with using a TR120 thermostat. And on that thermostat, it gives the user the ability to actually turn the fan on and off and switch to different stages in the fan as well, and also to put it back into auto. So these stages, this encode here is to help me decode what these are. Because in your program, it's going to go 0, 1, 2, and 3. Parts of the program can't handle 0, so I have to tell it what that 0 means. And then basically in my program for the thermostat, for my fan speeds, it's actually 3, 4, and 5. So I have to decode that from coming from my fan cycler. It's basically 1, 2, and 3. So I tell it that at stage 1, I want it to output a 3 to turn on my low speed. At stage 2, I want it to output a 4 for medium, and at stage 3, output a 5 for high speed. Right here where it says service is actually my program that I've written, and I've used select blocks to switch between a normal operation and to switch between my service button telling the fan speed what to do. So when I come in here, this is just basically a simple, like I say, simple program where I've actually gone in and told, here's the service, the link to that service button. And then I wanted to be able to turn that on, that feature on and off as needed. So I added that to that, and then what my duration that I want this to run. So I ran everything through a one shot here where once the button is pressed, it's it starts the one shot. As you know, the one shots can be a momentary deal as well. So I put a time duration on it of 300 seconds. And so that output on that one shot stayed true for 300 seconds. And then I ran that through another one shot for my runtime accumulator. And with the one runtime accumulator, basically I just have it counting for minutes. And so the whole program is gonna work for 4 minutes. So once I have, once that is done and I'm finished counting my 300 seconds, then it actually turns my one shot back off right here. And then this is actually going to my switch where it tells the switch to go back to 1, which is under my normal operation. And then with here, for the 4 minutes, I come out of there and then I add an additional 2 to that. So when I'm at 1 here, I send an output for 3. When I'm at 2, send an output for 4, and then on and on for 5 and 6. So if I push this button again, you'll see this actually switch, and then you'll see this whole deal simulate here. And what I did with this is when I hit true for this runtime reset is basically just going into the runtime accumulator and then basically resetting my runtime back to 0 so the whole count can start over again. So, and if I go back to my fan control here, if you see here, you'll see these start switching. To tell my fan speeds to come on. So one of the things that I did with this program is if they're using this button here for testing, and the purpose of it is that it was written for university dorm rooms. So if you have your HVAC department that is replacing a 3-feet fan in a fan core unit, once everything is done, then it actually helps, it cuts down on their time of having to get in touch with a building automation technician and then having that technician to simulate those different speeds to make sure that the fan was hooked back up correctly and everything is going to function the way it's supposed to. And then it alleviates them from having to go into the customer's room and then using the thermostat to try to cycle through to make sure that this would actually work. So it's set up for a span of 4 minutes. I made it to where it can be adjustable, and then they will see the fan cycle every minute. So like I said, if it was on, the first part of the program would be it'll go back, turn that unit off, and then every minute after that, it cycles through the different speeds. You can also use this for a number of different things. If you wanted to try to use this for, say, simulating my heating valves or stage heating to come on. And basically you can actually set it for, I want my, I have 2 stages of heat. I want the stage heat to come on, and basically if I turn on stage 1 and my discharge temperature goes up to 85 degrees, then go ahead, simulate stage 2 and see if I can drive my temperature up to 90 degrees. You can write logic in there that if the stage 1 wasn't achieved, then send you an alert saying that there is a problem with your heating because it never did or it never could achieve the 85 degrees that you set it for. So this button can actually be used in a wide range of different things here. So again, if I go to my heating logic, or my cooling logic, I can add something here to actually simulate that, actually starting with that button as well. So let's go here. I will add Boolean output, just say test. Eight. I can come out of the same select here. Let's just do this. See, everything's off there. Do anybody have any questions so far?
So I got a question on the service button, how you've got kind of the three different options. You can hit it so that it'll show up on your list. You can reset it to factory, and then you can do it for the programming side. Do all three functions still work, or do you kind of set it up, for what function you want that service pin to work?
No, all three services will still work at the same time. So like I say, with the reset, it's basically dealing with the power feature. So before it looks at the service button before the program actually starts up in the controller. So if you power it up while you're holding the button and it's held for a couple of seconds before it officially starts the program, then it knows that you want it to actually wipe your controller. Here in the config screen, it'll still show up if you actually take and push that button. So basically, let me go back to it here. For here, even if I took and pushed it as a momentary type deal, the service button still won't switch from out of heating and cooling. And I guess I forgot to say that. So if I'm using the service button for a few, 4 parts of the programming, they will have to hold the button down for a few seconds. So that's how it actually differentiates between the different functions. So if I was on my screen here under config and I push the button as a momentary deal, which I only have the one controller here. Well, actually I have a second one. So I can right click here, go to action, add serial number. I can manually put it in, or my second controller here on my test bench, I can just push it and it was just a momentary deal. And now I have my second Spyder 5 controller that came in. And here's the device ID and everything. So since I didn't change the other one, it took the very first one here that was on my list, or I could actually go in and manually put it in. But if I have a range in here, I have to stay within that range that I set. So So like I said, if you are doing wiping the controller, that's basically a combination between powering down your controller and powering it up while holding the button. To do the config here, to pull it into a property sheet, to list out all your controllers, is a momentary push. And then back here on the onboard IO, for it, you have to take and hold it down and hold it down for a few seconds, and then it officially switch. So this right here, it looked like it took a while to do it, but it actually does it a lot faster. It's just, this is sometimes it's actually slow to update. So, and then as soon as I let it go, this actually went back to false. But like I say, with my program here, you can see that it went back to 0. Whereas here it still say it's true. So it's just gonna take a while for my data to update here. And then, like I said, it starts the program from there. So any other questions?
No, it seems pretty easy.
And like I said, it's I did this one as a rewriting a program to look at some fan coil units, and then I heard Honeywell talk about it, but never seen anybody really demonstrate it. So I just took the challenge to see if I can go in there and get it to work. This part of the program, I'd have to say that it took me a little bit to get it to work the way I wanted it to, especially with trying to get from the cycler that actually goes stage 1, 2, and 3, and then you going using the fan portion of it to go through the TR120. So the customer have access to switch the fan speeds and everything, and then the user from the front end having the ability to use it as well. So, and like I say, once we go into the into your different fan speeds and everything, it actually goes 3, 4, and 5. And that is actually going to be back here in my zone logic. I think I put it there. Or did I? So I know I may be in here. So, which is this right here. I'm sorry, this here. So this is the manual command coming from the TR120. And then you have to go in and set your, what do you want it to do, using 5 states, which is auto, off, low, medium, and high. And then here is the states that you have to go through. So you can rearrange these numbers, but it is actually straightforward if I leave it as 0, 1, 2, 3, 4, and 5 that way, and then basically just go into my programming and then just basically adjust from there. And then the same thing for the BACnet enumerated output. We'll go in there and you would do the same thing, set the number of states that you have. And then here's my enumerated range here of what everything is set for. And again, like I said, the thermostat itself does 0 through 5. The enumerated range, you can't do 0, it's 1 through 6. And then that's where other parts of the program comes in, where I added this add block here. So when I'm actually at a 0 here, when it goes through this pass through, then I'm going to add 1 to that, which would give me my 1 here for off instead of 0. And then out to the to my other part of my logic here. Last week, like I was stating also, this is a silk device here. Right now, you see a broken link between these two. And the issue that I'm having, and I haven't gone back and tested it yet with since they've come out with the new firmware. The issue that I was having at the time was, if you see here, I have set as a network set point, and that is from the thermostat itself. And me trying to have the ability to actually write to it. So my logic behind it was, if the customer goes in, turns the fan off, put in a service call for saying that the unit isn't working, and then the VMS group pulls it up, sees that, hey, it was manually turned off, they should be able to manually put it back into auto, and then the customer would then they would be able to get the unit back on, or at least see what was going on. So if the automation group did something to the fan coil unit, it wouldn't necessarily lock the resident out from controlling their thermostat in their room. But the problem that I had was, when I made that link, if I went in and commanded anything, even if they went back to the thermostat and tried to make any changes, it would show that the changes was made on the thermostat, but it wouldn't physically make the changes in the program itself. So that part, that's the reason why this link is broken here, until I can figure that out, or until I can get an answer back from Honeywell on that. So. So, like I said again, this is a really neat feature, and I am actually glad that Honeywell did provide this for the controllers, because it can be used in a wide range of different things. If you have commissioning agents out there, and you can actually set these up for service buttons for them. If balancers was out there and they want to see your program work automatically, you can actually put this in as a service feature. Even for your customer, if they have to go out and do PMs or anything like that, they can go to the controller, push the button, you can write the program to actually run the whole controller through its whole sequence of operation, and actually come out with the ability to, you can come up with parts of your logic that actually comes back and report to you that parts of your program failed, or basically, I tried to raise my temperature up on my discharge temperature using the reheat, or I tried to drive the temperature down using a chill water valve or stage cooling, and it didn't work. And so it gives them, you can help them out with looking at different things to check out. And so you can kind of help them be proactive than actually reactive on that stuff. So. And I did beta test this in front of a customer, and they actually really love that feature. So. One of the things I went to show you guys last week, and I can actually show it to you now because I am live. So right here is one of those silk devices. And like I stated last week, anything dealing with the silk device of any of the TR40s up to the 120s, you want to make sure you do all of that logic first, because even if I take and move any of these blocks, you're going to always get this feature here where it says add/modify any silk function block requires manual teach. Please teach the modified controller after that. So if I come back to here, as you can see, it stated that my project was modified as if I added something to it or I deleted something out of it. It is just a functionality of the silk blocks that you have in your logic. So just please remember to actually, you want to make sure that you take and do all of that programming logic first, and then actually move it to the side to where you're not touching it. So, and it's just as simple as doing teach the controller, and it'll go through, which I just got an error. So with the newer program, before the newer firmware, before, the only controller that could benefit from the application for teach to controller was the VAV controllers. But now that the firmware is for both the unitary and the VAV controller is back at the same number, firmware revision, the application for teach to controller works for the unitary controller as well. And as you can see, even with me just trying to do the smaller teach for the controller with moving that silk block didn't work. So you would have to do the application for teach to the controller. And this one actually does take a little bit longer to download, because it is actually, if there was anything there, it got rid of it, and it's actually doing a new full download of the controller. So. And then my issue last week also with the firmware is if you're doing the firmware download on your controller, stay in that screen until it's actually finished, and don't try to jump to something else. It seems to stop or cause problems with that firmware download. So that was my issue last week when I was doing it, and then going out and going to other parts of the screen. So once I just left it there, it actually did finish the firmware download of the controller, and everything came back online just fine. So the download is finished. And I can come here, and these are some pre-built graphics that I started making. So have this, and then set parts that I was working on. So everything is not totally finished, but that's what we have. If there's no more questions at this time, we're gonna go ahead and end it. Next week, it's gonna be on another continuation with the Spyder 5 controllers. Next week, we're gonna go into the synchronization and things that you would have to do, and what you have to look out for synchronizing programs with more than one controller, and where do you go in and find inside of your program how to enable, or well, how to disable. So every block that you put in there is enabled to sync, but like say VAV boxes, you may have airflows, K factors and stuff that you don't necessarily want to change. So I'll show you how to go in and disable that and where to look for all of that stuff. So I appreciate everybody for joining me today with this.